Hi, today we're going to talk some more about how to use differentiation with motion problems. Let's quickly refresh. We know that the velocity is the first derivative of position, and the acceleration is going to be the first derivative of velocity or the second derivative of position, and also the speed. You find speed by taking the absolute value of velocity. So we have this problem. The position function of a particle is given to us by this function. Particle is moving along a horizontal line, and we need to find the velocity at 2. Well, to find the velocity at 2, you need to find the velocity function first. So v of t is going to be s prime of t, which is going to be 6t minus 7, right? And now to find the velocity at 2, to finalize it, you are going to simply substitute that, and that is going to give you 5. Find the speed of the particle at 2, you find the absolute value of velocity at 2, which is going to be 5 because it's positive, right? To find the acceleration at 2, you need to find the acceleration function first. So just a reminder, that's going to be v prime of t, right? And then to find the, sorry, no, finalized it, equals, it's going to be 6. So acceleration at 2 is going to be 6, and in this problem the acceleration is a constant value, it doesn't change, therefore it doesn't matter if you're doing trying to find the acceleration at 2 or 3 or 1, it's still going to be 6. Let's take a look at the next problem. So we have here a situation where a particle is moving along the y-axis. We have this position function given to us on the interval from 0 to 5. First thing we need to do is find the velocity function. So v of t is going to be y prime of t, which is going to be 2t minus 6. So at what values is the particle at rest? The particle will be at rest at points where the velocity is 0. So that's one important thing that you need to know. So we do want the velocity to equal 0. So where is it going to happen? So if you set 2t minus 6 equals 0, that is going to give you t equals 3. Right? So that would be our answer. So now the question is, at what values of t is the particle going to be moving up? Well, let's first understand this. The particle is going to be moving up when the velocity is going to be negative. Up when the velocity is positive. That means that the velocity of the particle is positive. And the next question is asking moving down. That's when the velocity is going to be a negative value. A typical approach for this is going to be to draw a number line with our 0 for the velocity there, so that's 3. Make sure you label all your graphs. And what we do is we determine the signs of the velocity to the left of 3 and to the right of 3, which is easy. You pick a value, plug it into the velocity function, you will see that there's going to be minus here and a plus there. Correct? So now what we need to do is write our conclusion. So we know that the velocity is going to be positive from 3 and up, right? Actually, we're restricted, we're only going up to 5. So we can say that moving up because, on the interval from 3 to 5, don't go beyond 5, because v of t is positive there, right? And in similar fashion, for when it's moving down, it's going to be moving down on the interval from 0 to 3. Remember, you can't go to the left of 0 because v of t is negative there. I do want to mention one thing. If you happen to be taking AP Calculus, These number charts are a great visual tool. They help you, analyze things quicker, but they're not acceptable as a justification tool, so you will need to write things in words, just like what I did here or there. Okay? Next problem. Particle is moving along the y-axis. Its position is given by this formula. So we have several questions here. Let's do first one. Find the velocity function. Well, v of t is going to be y prime of t, which is going to be 3t squared minus 12. When is the particle at rest? So we need to set up the velocity equal to 0. So 3t squared minus 12 equals 0. If you factor it all, you can factor out 3. Then you get t squared minus 4 equals 0. Use it 3 times t minus 2 times t plus 2 equals 0, which is going to give you two values, right? But, so one of them is going to be t equals 2 and the other one is going to be t equals negative 2. And that is if you're just solving this quadratic equation. The thing is that we are restricted by the interval from 0 to 8, it says right here. So negative 2 will not be an acceptable answer for us. So the only answer that we can go with is going to be t equals 2. Be very careful. For what values of t is the particle moving up? Well, you're going to have to make a number line. So we are restricted by 0 here, by 8 on the other side, and somewhere over here it's 2. It doesn't have to be to scale. You just need to get an idea of what's going on where. So the signs, if you plug it in, the signs will be going to be negative here, and it's going to be positive here. Right? So as we already know, as I told you earlier, you need to make sure you label your graphs. So when is it moving up? So it's going to be moving up on the interval from 2 to 8, because v of t is positive there. For what values is it moving down? Right, moving down. On the interval from 0 to 2, because v of t is negative there. And the last thing we need to do is find the acceleration function of this particle. So the acceleration will be the first derivative of velocity. So a of t will be v prime of t, which will be 6t. Okay? And that's how it works. Alright, the next problem. An ant is traveling up and down the stem of a flower. Its velocity is given by the velocity function, so be careful, you are already given the velocity function here. You don't need to find it. So the question is, at what values of t is the ant at rest? We already have the velocity function here, so we're going to set it equal to 0. So it's going to be t minus 5 squared times t minus 2 equals 0. That should be pretty easy equation to solve. It's already factored, so it's going to be t equals 2 and t equals 5. Those two values. Okay, so now we need to find when the ant is moving up. So we're going to draw a number line. We do have 2 points here. Remember, we are restricted by 0 and 10. So now we need to figure out the signs. So if we plug in a number between 0 and 2, for example 1, this part is going to be positive, this part is going to be negative, so you will have a minus sign here. Between 2 and 5, so this is still positive here, This is positive, so positive. And over here is going to be positive as well. And let's make sure we label it. So this is v of t. Okay. And when is it going to be moving up? Well, it's going to be moving up on anywhere where the velocity is positive. So it will be moving up on the interval from 2 to 5 and 5 to 10, because v of t is positive there. There may be some discussion, and it's a more of a philosophical discussion here. What about the 5 itself? Can't we just go from 2 to 10? Maybe, but I'd be careful here, because technically at 5 the end is at rest and it's not moving up or down, so be careful there. Okay, and the last question here is find the acceleration of the end at times where the end is at rest. So we already found those values in part A. So we need to find the acceleration at 2 and at 5, right? It's right there. But first of all, we need the acceleration function. So a of t is going to be v prime of t. Alright, so now we need to differentiate this, and it's a little bit of a challenge here because you have to use the product rule and all these other things. So it's going to be 2 times t minus 5 times t minus 2 plus t minus 5 squared times 1. This will be the derivative of this, and if I were to make it look a little nicer, I can factor out t minus 5 times 2 times t minus 2 plus t minus 5. There's a little bit of algebra involved here. And if we simplify all that, t minus 5, here we have 2t minus 2, this is 2t minus 4 plus t minus 5, this is what we have in brackets, which means it's going to give us 3t minus 9. Okay, so this is our velocity function, acceleration function, and all we need to do now is plug in 2 and plug in 5, right? So a of 2 will be, it's going to be 2 minus 5, it's going to be negative 3, and that's going to be 6 minus 9, which will be negative 3, so it's going to be 9, and the acceleration at 5 will actually be 0. Okay, that's how it's done. I got one more problem here, and this one will require us, well, you don't necessarily, doesn't require you to use a graphing calculator, you can actually do it without one, but so I graphed this function. This is the velocity function that's given to us, and I'm using TI Inspire with the TI-84 keyboard, and this is what the graph of this velocity looks like. What you cannot see very clearly here, the graph is actually going up above the x-axis here from 0 to 1, gets 0, then goes up again, and then goes down. Okay. Do want to show you one other thing. So the interval here that we're working with is from 0 to 6. A graphing calculator may be needed, and if you're rounding your answer, especially if you're working with AP Calculus, the expectation is they're going to be rounded to 3 decimal places. So at what values is the particle at rest? Since this is already the velocity function equals 0, you should be able to see that it's going to happen at t equals 1, and it's also going to happen at the values where the value of sine is going to be 0. Value of sine is going to be 0 at 0 and also at pi, so t equals pi is another value on the interval from 0 to 1. 6 is the next time sign is going to be 0 is going to be a 2 pi, but 2 pi is 6 and 6 plus change, and that's going to go beyond 6. Alright, why? Because, well, this is basically justifying this. For what value is the particle moving to the right? So it's going to be moving to the right when the velocity is 0, so v of t is positive, when we are on the interval, so it's going to be from 0 to 1, and then there is going to be also from 1 to pi. Okay, so that's a positive. And when is it moving to the left? That's when the velocity is going to be negative, and it's going to be when you are going to be from pi to 6. Okay, and now we need to find the acceleration. To be honest, this function is not a very nice one to differentiate. It could be done, but since it says a graphing calculator may be needed, we're going to do that. So what we're going to do is I'm going to show you how you can find the derivative of the function using your calculator. So let me show you how it's done. So when we're in the graph mode, what we're going to do is on this particular calculator, your graphing calculator may work differently. This says calc, so we're going to press second trace, which is taking us to the calc menu. One of the things that we have here is dy over dx, which is option number 6. So we're going to press that, and we're just going to manually type in the point that we want. So we're going to press 2 as one of the values, and we're going to get 0.42073. So what we can write here is that the acceleration 2 is going to be 0.420 or 0.421. By AP standards, if you're talking about an AP Calc exam, even though this one's not rounded, this is what we call truncated. This answer is rounded, but they're both going to be acceptable. Okay, and then for that to be done at 4, let me do this first. Okay, so when we're gonna hit second trace, and we're gonna go to our dy over dx option, which is the derivative, and we're gonna manually type in 4, and we're gonna get negative 3.127. Okay, so the acceleration at 4 will be negative 3.127, both rounded or truncated. Okay, this is how it works, and I hope this helps.